In this lesson, we are going to be investigating and looking at the surface area of a cylinder. A cylinder is kind of like a pop can, for example. So the surface area of a cylinder, the first understanding that we need to recall is that surface area is the sum, so we're adding the sum of the areas of each face of a 3D object. So we're going to find out the area of every single face when we unfold it into a net, and then we're going to add it up. So a cylinder, if you unfold the cylinder, and you can look in your textbook, and if you don't understand what the net looks like, I have some shapes that you can look at in class if you'd like to, but a cylinder, if you unfold it, has three faces. It has two circles and one rectangle, which seems a little bit weird because there's a curved surface. But if you do unfold a cylinder, it looks something like what I have in front of you. And again, you might want to pause this to copy this down as we go. But here is the formulas that you will be given on any quizzes or anything for the surface area of a cylinder. But you still have to understand where they're coming from, because in some cases, maybe the cylinder is missing one of the surfaces. So you have to be careful about how that works itself out. But if you want to understand it from a net perspective, one thing that we know is that the area of a circle is pi times radius squared. And you're going to have to remember that radius is halfway across a circle. So each of these circles would have an area of pi times radius squared. And that middle part, if you unfold it, and if you want to understand why, I'm more than happy telling you in class. But the area of the unfolded rectangle is pi times diameter times the height. And again, pi is equivalent to 3.14. If you want to think about it from a formula perspective, it actually makes complete sense. The formula is basically going to tell you the exact same thing. The formula is 2 times pi times r squared. Again, that shouldn't shock you because it's two circles. That's where that part of the formula comes from. So the surface area is 2 times pi times r squared, two circles, and then plus a pi times diameter times the height. And that's where this factors in. So that formula will be given to you on anything that you have to accomplish for surface area of a cylinder, okay? So you won't be expected to memorize it. So let's look at a couple of examples and just apply what we know. So to calculate the surface area of this particular cylinder, we're given the radius and we're given the height. So a couple of things we know is that each circle, again, I'm not going to use the formula, I'm going to use kind of the net here. Each circle is pi times radius squared. So what we know is that each circle is 3.14, and radius squared does not mean radius times 2. That's an exponent. Radius squared means radius times radius. So it's going to be 3.14 times 5 times 5. And this area here, same thing, 3.14 times 5 times 5. For the middle rectangle, if we were to unfold this curved surface, it would become a rectangle. You should remember that it's going to be pi times diameter times height, which is 3.14. And the diameter of this cylinder, let me maybe do this in purple. If the radius is 5, the diameter is the entire way across the circle, so the diameter is 5 times 2, which is 10 centimeters. So it would be 3.14 times diameter, and the height's equivalent to 15. So if we calculate those three parts and add them up, we're going to have the surface area of this cylinder. So 3.14 times 5 times 5, each of the circles is 78.5. Centimeters squared. Again, you're going to want to pause this and maybe try the next question on your own if you'd like to. It's a little bit tricky. And review this lesson if you're having some troubles finding out the surface area of a cylinder. So the middle rectangle is 3.14 times 10 times 15, and that's 471. Centimeters squared. So the total surface area is the circle plus the rectangle plus the circle. If we add all three of those up, so 471 plus 78.5 plus 78.5, we have a total surface area of 628 centimeters squared. All right, in this next example, the only important thing to understand as you're looking at this next example, and maybe try it yourself, is that even though it's been tilted on its side, you still have to picture the height and the diameter and the radius appropriately. So if you want to picture this thing again tilted on its bottom, so maybe picture it tilted, the thing that you'll notice and look at carefully is that 8 centimeters is the height. Okay, so don't mistake the 19 for the height of this cylinder. So if you tilted it onto the circle, so the circle was the base, might be a better way to picture it. That 19 is actually the diameter. So the only thing that you have to think about now is we have to calculate the radius, and then we'll look at the surface area and be done. The radius would be half of 19, because radius is half way across a circle. So your radius in this case would be 19 divided by 2, which is 9.5 centimeters. So let's go ahead and figure out the areas of every surface, and then we'll be done. So each circle, so this circle here is 3.14 times radius, so times 9.5 times 9.5. This circle here, the exact same thing, 3.14 times radius. And finally the middle rectangle, if you unfold it, so this rectangle, if you unfolded it, is pi times diameter, which is 19, times the height, which I stated is 8. So if we calculate all those parts, 283.385. Again, you might want to pause this at any point in time to try and finish it yourself, and then see if you have the correct answer afterwards. All right, so here is the surface area of this cylinder. We've got 2 circles, we've got the middle rectangle. If we add those all up, we're going to have the total surface area. And here it is, 283.385. Just going to times that by 2 since there's 2 of them. And then I'm going to add the 477.28. So it's 1044.05. centimeters squared. And the only thing to be careful of if you are working on these problems is what happens if it's missing one of the surfaces. So if it doesn't have a top, then it will only have one circular surface.